Okay. Previously we talked about topic 2, the example from page 42. Now we talk about topic 3, okay, which is we're gonna talk about brief intro to submerged because topic 3 itself is forces acting on a submerged body. Okay, so compared to hydrostatic, it's a little different, although they have relation. And then we'll talk about the two basic shapes for analysis when the body is being submerged. Okay, so it's in terms of plane and in terms of a curved surface. And then we'll use um, some equations, some method to actually solve for that. So as mentioned earlier, this two part will be pretty much very tedious. So I'll just start now. So topic 3, um, this says that the surface of where the forces are acting on the surface of this object. The keyword is the surface of the object. Okay, so the forces acts on the surface of the object, and then it can be with the when the object is being submerged, can be say that it is within the sea, or it is in the very high air where the pressure of the air is different from the atmospheric, and also from the inside of the airplane. Inside of the airplane, as you know, is pressurized, so it's much lower than the pressure outside. So therefore, there will be a you can say that the aeroplane is submerged inside the air, the atmospheric air itself. So this is the key concept that's saying the forces acting on the surface of the object, and therefore the forces that act on the surface of the object, there are two basic shapes that we can analyze. The first one is actually onto an inclined plane, which is the ship hull, okay, inclined. Another one is the curved surface, okay, that deals with fx and fy. So we can say that it's on upon submarine. Okay, so now we talk about hydrostatic. So just to let you know, we are really clear of this one. So we are just gonna talk about this. So this video is mainly on this thing, okay. And next video we'll talk about, maybe if we got time, then I'll talk about example for this one. Okay, so yeah, where am I? Okay, so in order to attempt this question, the first thing you need to do is to understand what is the objective. The objective itself is to find the forces, acting on the plane itself, okay, and the location of the force. Because um, you can say that it's the location of the CG of the force, I would say. Okay, the force is it's all around, it's UDL, okay, uniformly distributed along all the planes. Just that there will be a force that is actually in some position that is in the CG of the plane itself. So we are gonna find where is actually the largest of the force acting on the plane itself. So you take on understanding from top, okay, Newton meter. So by now, yeah. And then our first step is to do, okay, I will write down, is to define our FR, okay, our force. So as you know, pressure is equals to force over area, okay, from the topic 2. So in order to find force, you just bring the area upwards. So force is equals to PA. And from topic 2, we also learned that pressure can be written as rho GH, right? Which is also rho GH. So which is also rho G itself is specific weight. Okay, specific weight is not equals to specific gravity. So you have to also make sure that. So yeah, so you can rewrite pressure in terms of this term over here. And then since the plane is inclined, okay, as you can see, h is this vertical length. If it's inclined, okay, you're gonna use sine theta, okay, y sine theta. So this is y, okay, from whatever point, from the so-called the pivot point of the plane itself, where the largest force is acting on the location where the largest force is acting. Okay, so this is y. Okay, y So you have to, when you are attempting this question, if they did not label you anything, make sure you know that your y is to the position where the center of the force is acting on. Okay, so by trigonometry, okay, if you, because I also want to check, so if let's say this is hypotenuse, we call it HYP, and then you want to represent H as HY as, you know, the relationship. So as you know, this is O, okay, this is opposite. So in this manner, we'll have this, right? So it's just, so the opposite itself is hypotenuse times sine. If you remember, sine, okay, to Akaso, so this is the so opposite or divided by hypotenuse. So hypotenuse multiply by sine theta, right? So this is why we have the equation over here. So with this step, you will know that OPP, the opposite side, which is the H itself, can be re-represented in terms of y sine theta. Okay, so this actually is a proof, because anyway. So the area itself can be expanded in terms of by dy. It's more change of dy. As we can also say that this is actually dA. Okay, this is dA. Small change of area. So you give me a minute. And therefore, this B itself is the breadth of the you know, the plane. Okay, so if it's in a 3D, okay, if it's in 3D, the plane itself, the length of the B is actually into the picture. So if you were to say, okay, if it's 3D, then this will be the plane. This will be the length of B. Okay, so this is Y and this is B. Okay, and the thickness itself is, you know, another thing. But we're not gonna talk about thickness. So it's just B. So B is into the picture. Just let you know. And then let me see. Hold on. Okay. And then you can bring this B out because it's a constant. So you just have this equation over here. So far I've talked about deriving expanding pressure equals to force over area. Okay, so force is equals to pressure over times area. So this thing is being expanded with all this thing being described over here. So far I talked so much is all about simply force equals to pressure times area. That's all. Okay, and then with this, okay, our objective is to solve for our FR, right, our resultant force, which is perpendicular to this plane actually. So we just solve for FR using this equation, that's all. Okay, and then when FR is found, you can actually find your position where actually the center of the force is acting. Okay, the reason is that you have to know where is the largest force acting on the plane itself, so you can counteract somewhat. Okay, and then so by understanding the torque, okay, if you remember, the torque itself is also, but if you remember the seesaw, so if you put a force over here, multiply a distance from the pivot, this is the torque. So you turn in the moment direction in this manner. So similarly, as you can see, the force itself is acting on the plane. So when the force is acting on the plane, because this is the pivot, okay, so this one will actually turn, okay, it will actually spin and, you know, flow, or maybe perhaps it will actually flow downwards, okay, in this direction. You will actually, when you submerge, right, it will actually go down in this direction, I think. It's likely to turn and tilt and tilt and tilt, and then, you know, and then eventually it will fall down to the seabed itself. So this is, I may be wrong lah, okay, but this is what I think. So taking the concept of force times the perpendicular distance, force times perpendicular distance, okay, you would actually use this method to actually solve for the position, or the position where where the center of force is. I would say center of force, but I may be wrong saying that term. But all in all, it is just this divided. Okay, anyway, I'll just show you this first. So it's analogy to force the torque. So force on perpendicular distance from pivot. And when you bring the force downwards, you can actually find the perpendicular distance from the pivot, which is what we are finding. The perpendicular distance from the pivot, which is what we are finding, which is this. Okay, this is the pivot. Okay, this is the pivot, and then this is the distance. Okay, so it is just, yeah, intuitionally it's pretty much tough to say. So as I said earlier, this is not a pivot, damn it. Okay, anyway, so it takes on the concept of torque. Okay, but yeah, this will be the distance we are finding, and therefore same thing. So the origin itself is actually the pivot. Okay, now the origin itself is the pivot. So you apply a force perpendicular to the distance. You get a distance from the end from where you apply your force to the pivot, which is the origin itself. Okay, which is the sea level. Okay. So with this said, I hope I am clear. Okay. So as you know, force multiply the distance is equals to torque. So therefore, we take this force we found earlier. Okay. This is the force we derived from the very first part. Okay. This force we multiply by the perpendicular distance yr. Okay, so this y can be this one. Okay, so therefore this one will become y square. Okay, although it may don't sound much intuition, but this is how it is, and I just realized I can explain, but I need to explain, but I don't know how to explain. So yeah, because I also don't know how it works. But just know that when you are dealing with this, force have to multiply with the perpendicular distance. And when you multiply in the perpendicular distance, okay, from the origin O, you just put the y into the integration y square. So divided torque. So this one will become torque. Okay. So torque divided by force, which is also this equation. Okay, we didn't change anything now, so we just plug in the force over here. Because everything is in terms of integration. Okay, this all two of these are the constant. You can straight away cancel it. Okay, this is shortcut for only incline. For curved surface, okay, for curved surfaces, I don't think we can do that. Maybe in the later video then I'll just try. So apparently for this type of surfaces you cannot do what I've done earlier. So be very careful, you cannot do this in curved surface. Only incline you can do this. Okay. So the difference is only the integration y square and divided by the integration of y itself. So you divide, you can actually find your y. So with this whole concept, hopefully I can give you a good intuition on how everything works. And then next video I'll talk about applying it. So just to summarize, it's pretty easy. Okay, it's just to find a force, you use force equals to pressure times area, and then you expand it into this, and then because you need to your objective is to find force and the location of the force. So you use the relationship of torque, okay, where this is the force applying onto a perpendicular distance, where the pivot itself is on the origin. So this is the perpendicular distance from the origin, and this is the force. So apparently this dude will actually move there, you know. So with this as you can see, this is pretty simple, okay. Although I write so many things, but it's just two things. But although it seems simple, but you need to analyze a lot of things. So yeah, so next video I'll just talk about it. So bye bye.